Hello, Coach Holmes here, and today we're going to be talking about triangles in a coordinate. Now, this time instead of actually having triangles in a regular figure or outside the grid, we're actually going to do it in a graph. And we're going to be able to determine what type of triangles they are on a graph. But there's a few things that we need to refresh our memory. We need to refresh our memory on distance formula. So what is distance formula? Distance formula is D equals, let me do it in blue so that way it knows what you're writing. Distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. That is my distance formula, okay? Now, we also need to remember midpoint, which midpoint formula is actually x2, let me rewrite that. x1 plus x2 over 2, comma, y1 plus y2 over 2. So that's our midpoint. So that's our midpoint formula. And we got to also remember slope, which slope is m equals y2 minus y1 over x2 minus x1. Now, the reason why the slope is going to be important for us is that it's also going to help us out as far as finding right angles. Because remember, any perpendicular angles are going to be the reciprocal of the opposite reciprocal of it. Which basically means that if I have 2/3 here, in order for it to be reciprocal, in order to be perpendicular, I have to flip the fraction and change the sign. Okay? That's if I'm going to be looking for right angles, which I should, but I'm only going to look for it if it looks closely similar to it. If it looks close to be a right angle, I'm going to look at it. Because there are some angles, like for example, this right here, that can't be a right angle. That's nowhere near as close. So obviously, I'm not going to look at every angle for it, but if it looks closely similar to a right angle, I am going to check it. But the reason why I say that is because I want to determine what type of triangle this is. Well, looking at the angles, I have a acute angle, another acute angle, and I have obtuse. So I do know that I have an obtuse angle. But now, I also want to think, what type of side is it? Is it like a scalene triangle? Is it isosceles? Is it equilateral? Well, I gotta know the distance for it. So, looking at it right here, I know I go 1, 2 units. Simple as that. If it's horizontal or vertical, just count the number of units you have and just say, well, that's my distance. That's the distance for that length, is 2. Just count if it's horizontal and vertical. However, if it's like these two, it's kind of hard to tell. It's kind of hard to tell what the units are, what the distance is. That's why we have distance formula. So for the first one right here, and I'm just going to split this one in two. So for the first distance, which I'm going to use the points -3, 4, and 2, 1. I want to use that distance. So give me 1 sec. Now, I want to be able to find a distance for it. So remember, the first thing I want to do is I want to label my x and y values. So x1, y1, x2, y2. So I know that for distance formula, it's going to be 2 minus -3 squared plus 1 minus 4 squared. Well, the 2 negative makes it a positive, so I'm going to have, I'm sorry, I'm going ahead of myself. 5 squared plus 1 minus 4 is -3. 5 squared is 25, plus negative 3 squared is 9. I'm going to add them together to give me 34. But what is the square root of 34? Check it in my calculator, 5.83. So this distance right here is 5.83. So obviously it cannot be equilateral because these two distances are not the same. However, if it's isosceles, this length right here has to be 5.83 as well. Kind of hard to tell, but I don't want to take my chances. So my second length is going to be negative 1, 4, and 2, 1. So I want to be able to find those lengths. So, but again, using distance formula, x1, y1, x2, y2. So I'm going to say 2 minus negative 1 squared plus 1 minus 4 squared. Well, I know that the two negatives make it positive, right? So 2 plus 1 is 3 squared plus 1 minus 4 is negative 3. So then I'm going to do 3 squared, which gives me 9, plus negative 3 squared, which gives me 9 as well. Add them together, I get the square root of 18, which gives me 4.24. Now, looking at it, knowing the lengths, they're all different lengths, which means it makes it an obtuse scalene triangle. And that's what I'm looking for. I want to be able to find the lengths of each one and identify what type of triangles they are. Now, let's say we have this figure, we have these points right here. Prove that the triangle is an isosceles triangle. So, I'm having the point 3, negative 2, negative 5, negative 2, negative 1, 1. Well, it looks like an isosceles triangle, but I want to prove it, okay? Which basically means show your work. We want to show our work to know that this is an isosceles triangle. Well, first off, looking at this length right here, I go 1, 2, 3, 4, 5, 6, 7, 8. So obviously that length is 8. So really, looking at it, I mean, just looking at it, it looks like these two are the equal lengths. Okay? But it looks like those two are the equal length. So I want to use those two lengths to prove that it's an isosceles triangle. So I have negative 4, negative 5, negative 2, excuse me, my fault. Negative 5, negative 2, and negative 1, 1. So, looking at it right here, I'm going to go x1, y1, x2, y2. So using distance formula, I'm going to go negative 1 minus negative 5 squared plus 1 minus negative 2 squared. Keep messing up with that parentheses. So again, I have both occasions where I have to change the negatives into positives. So I have negative 1 plus 5, which gives me positive 4 squared, plus 1 plus 2 is 3 squared. So then I'm going to have 16 plus 9, which gives me the square root of 25. Which actually, square root of 25 is actually a perfectly even number, which is 5. So the length here is 5. So that means, since I'm looking for an isosceles triangle, this length has to be 5 as well. So I want to be able to prove that. So 3, -2, and -1, 1. So I'm going to label it x1, y1, x2, y2. Now, so again, I'm going to go -1 minus 3 squared plus 1 minus -2 squared. I don't change the sign for this, but I do change the sign for these two right here. Now, -1 minus 3 actually gives us -4. 1 plus 2 is 3. -4 squared is 16. 3 squared is 9. Add them together, I get square root of 25, which happens to give me 5. So we just proved that this is indeed an isosceles triangle, because all I'm looking for are the two equal lengths here, okay? So again, we're basically trying to classify triangles on a grid, but we have to be able to know our distances, we have to know our slopes, because we do have to keep in mind about right angles and perpendicular angles. And midpoint will be something we'll go over later on in the semester. But the big key to this is that I want to be able to classify triangles on a grid. Thank you and have a good day.